8 billion tons. That's the amount of CO2 emitted by industries such as cement, steel, and petrochemicals, which accounts for 22% of annual global CO2 emissions. Now, the problem with these industries is that CO2 emission is embedded within the process, and therefore the only way to fully decarbonize them is to use carbon capture. Our current carbon capture capacity is 43 megaton globally, and the carbon capture capacity we need by 2040 for countries to be able to achieve their CO2 reduction targets by 2050, based on IEA report's announced pledges scenario, is 2,000 megaton. That means that in less than 15 years, we have to increase our carbon capture capacity by more than 50 folds. This both shows the scale of the challenge, but also the opportunity that is in front of us. So what is the challenge with carbon capture? The problem is not the technology, but it's the huge additional cost that carbon capture adds to these industries, basically eating through their small profit margins. And if you look at the cost breakdown of carbon captures, you can see that almost 60% of the cost of carbon capture is associated with energy and material cost. And we have two core innovations that addresses both of these problems. First is our patent-pending sorbent, LimeLoop, that can capture 36 times more CO2 over its lifetime than natural limestone. This reduces the cost associated with material by more than 80%. But it gets even better, because limestone is the main feedstock in cement production, which means that LimeLoop can be reused in cement for clinker production after its lifetime, making our process first waste-free and also the most feasible solution for cement decarbonization. Now let's talk about the energy. Energy is a bit trickier because based on the second law of thermodynamics, you need energy to separate CO2. You can reduce it, but you cannot eliminate it. But we can eliminate the cost associated with energy. How do we do that? Well, our solution divides carbon capture operation into two modes. During carbon capture and energy generation mode, our solution continuously captures more than 90% of CO2 from industrial flue gases and produces high-temperature process heat at 700 degrees C. In parallel, and only when cheap electricity is available, the CO2 storage and sorbent regeneration mode is on, whereby heating the sorbent using electricity, the stored CO2 is released in form of pure stream of CO2 that can be transported into the storage or utilization plants. This also regenerates the sorbent for future use. This operating scheme significantly reduces the cost associated with energy. First, because we use cheap electricity, but also because of the savings that the plant will have due to having continuous access to high temperature process heat. All of this leads to more than 80% reduction in the cost of carbon captures. So to summarize, our cost of carbon capture is considerably lower than our competitors. Our sorbent regeneration is potentially greener because we use electricity. Our solution is waste-free because, as I mentioned, our sorbent will be turned into cement after its lifetime. And in terms of heat storage capability, just comparing it to, for example, Rondo Energy, a company that provides thermal batteries only, our solution has a higher energy density because we store heat as chemical energy in our process, and we have a competitive efficiency. Our team presents a balance between experience and expertise. We have 3 PhDs in engineering and 2 MBAs. And our team is uniquely qualified due to a blend of deep technical expertise, industry experience, and a strategic insight. To date, we have tested our sorbent lime loop under relevant environment up to 100 cycles, increase its TRL to 5, and file a patent on its manufacturing process. We have also built a small-scale proof of concept of our carbon capture heat battery solution, demonstrated it, and increased its TRL to 4, and file a patent on that aspect of the technology as well. We are launching our seed round in April, and we want to raise £1.5 million with 3 main objectives. First, we want to scale the manufacturing of our lime loop. Second, we want to do a live flue gas test of our lime loop, increases TRL to 8. And finally, we want to demonstrate the carbon capture thermal battery solution at a kilogram scale, increasing its TRL to 5. Just to re-emphasize, we are unlocking carbon capture commercial viability through our novel enhanced sorbent lime loop and our innovative carbon capture technology, carbon capture heat battery. If you'd like to learn more, please head to our website at Remedium at www.remediumenergy.com. Thank you.